Here's an example from the book that someone asked about, so I want to go through it. You've got two cases, case A and case B. In both situations you have a big block A that's identical. And in the first case you hang a block that weighs 10 newtons on it, and so this means it's got a weight, and I'll call that block to be M1. So it's mg equals 10 newtons. We call that the weight. And in the second case you just pull on the rope with a force of 10 newtons somehow. And the question is, which case will block A have the greater acceleration? So let's look over here on the right side. So with the rope and pulley, so the rope and pulley are massless and frictionless, and so basically what happens is if you tug on this end with some force, the other end is going to have that same force. And so basically on block A is going to be a force of 10 newtons. And if I look at the acceleration of block A, the force is 10 newtons divided by whatever its mass is. And so that would how I would find the acceleration. Now over here, there's a force acting on this block here, and the force m1g equals 10 newtons. But the problem is when I try to find the acceleration, so I take the force, you got to remember that you always got to do the total mass of all your objects. So this force of 10 newtons is actually moving both blocks. Okay, and so the force is that same force. It's going to be 10 newtons. It's that mg, but it's moving block A and what I named block 1. So since there's a bigger mass, okay, then the A in case A, so this is case A, this is case B, and so the way it'll work is the acceleration of B is going to be bigger than the acceleration at A. So that's one way to think about it. I also had to give different ways. Here's another way. It's maybe a different mathematical way of looking at it. And so like we said over here, basically the force on block A is going to be 10 newtons. Now over here, let's look at this block here and do Newton's second law to it. So there'll be some tension upwards, there'll be the force of 10 newtons downwards, and then this object is going to have an acceleration in the downwards direction. So if I look at my Newton's second law like so, all right, I'll get a positive t, that minus 10 newtons, and it's going to equal negative ma because it's accelerating in the downwards direction. And so if I solve for the tension, I get 10 newtons minus ma. And so what happens is over here on block A, the tension pulling on it we know is exactly 10 newtons. All right, so that's the case B. Now the tension in case A over here is going to equal 10 newtons minus ma for whatever, again, I'll call it the m1 of that mass times A. So because in this situation here, because the block 10 newtons is accelerating downwards, I know that the tension is going to be a little bit less than 10 newtons. All right, because you have to have, whenever you do Newton's second law, it's like these two forces are battling. The force that wins is the direction of the acceleration. So if the acceleration is downwards, the 10 newtons has to be bigger than the tension TA. All right, and so the TA has to be less than 10 newtons, and so since the TA is what's pulling over here, less than 10 newtons, A is going to have a smaller acceleration than B.